So the stuff we're going to do today is very similar to what we just did. Okay, let me just go through a couple of, I'm not going to go through every single one of these, but remember the if-then statement? We said if the lines are parallel, right? I'm shorthanding this very, very much, okay? So if you have parallel lines, then we had a bunch of stuff, right? We said that the corresponding angles were what? Equal. If you have parallel lines, then we said that the alternate, I'm just shorthanding this, the alternate interior angles are equal. What else? Alternate exterior angles are equal. Can you remember any of the other ones? Yeah, we just said that, alternate exterior. We said the consecutive interior angles are what? Not equal, but what? Right. We said that the consecutive interior angles are supplementary, right? All right, so we learned a lot of stuff about this. But what did we start with? What was the if? If you start off with what? Parallel lines, okay? So if we start off with parallel lines, then all this stuff is true. You got it? We even had a question on the last homework that said, okay, what if those lines were not parallel? Could you say that the alternate interior angles were equal? No, you couldn't, okay? But here's what we're going to do today. Today's a little bit different, but kind of the same. With that being said, let me show you what I'm talking about. So I'm not speaking in circles here. So what if you had a situation like this? This is basically what this whole entire lesson is about. I do not put any arrows on here to indicate that they're parallel to each other, okay? So I don't know that they're parallel, but I do know this. What if I knew that this was 130 degrees? And what if I knew that this was 130 degrees, okay? If I said that this angle was equal to this angle. Now, at first, I don't know that these lines are parallel. They did not tell me that the lines were parallel, but what did they tell me? They told me that this angle and this angle were equal to each other. What do you think that tells you about these two lines right here?
So I think that they're going to be like adding up to 180.
On these two right here?
No, he means the other angle. Like the other angle.
Like this one right here? Like this one?
Or the opposite,
yeah. Yeah, okay. So if they told you this was 130 and this was 130, then you could say what? This was 50, then this would be 50 because they're vertical angles, plus they're supplementary to this, right? So these two are supplementary, these two are supplementary. What's this going to be? Well, it's going to be supplementary to this or equal to 130, right? And you could come down here and do the same thing, right? So this would be 50, this would be what? 130, and this would be 50. All right, so all that, you know all those angles just because I told you that 130 was equal to 130 right here. But what do you think that tells you about the lines, Gideon? That's right. So it's a little bit different. You're not starting off with parallel lines, but you're starting off with two lines cut by a transversal. Not parallel lines necessarily, just two lines cut by a transversal. Do I have to move you again? I don't know, but she's reacting from you, I think. I have a feeling. I have a feeling. Because she wasn't doing that before you sat there. So look, if these two are equal to each other, what can you then say about these two lines? Then you can say that they're parallel. Okay, that is it's actually, I don't think it's a theorem. Let me go back in my book right here. It's been 10 years since I've taught geometry, so I might have to go back and review a little bit. Yeah, this is a postulate. Okay, this is not a theorem. This is a postulate. To you, it doesn't make that much difference, but we can't prove it. It's just an accepted fact that if I told you that this angle was equal to this angle, now what are they to each other? What's the relationship between them? They're equal, but what's the name? This is in the top left. This is in the top left. They're corresponding angles. So here's what our postulate says. I'll just bring this down. So let me just make sure. If two lines are cut by a transversal, I'm going to write that down. Now, did I say they're parallel? No. Okay, if two lines are cut by a transversal, do we have that situation here?
Yes.
Yeah, absolutely. Then Oh, I'm sorry. Not then, not yet. Okay. Transversal. And, okay, that's a little different. And the corresponding angles are equal. Isn't that what they told us at the beginning of this? Right? They said that 130 and 130 are the same, and they're corresponding angles, and so they're equal to each other. So if two lines are cut by a transversal and the corresponding angles are equal, comma, then what must be true about those two lines? That's right. Then the two lines that we talked about earlier are parallel. I'll put just the symbol for parallel. Okay? So this is a little different. We kind of switched the if and then around than what we did yesterday. So this one, it just says, if the corresponding angles are equal, then the lines are parallel. Yesterday we said what? If the lines were parallel, then the corresponding angles are equal. You see the difference? All right? So they're not telling you right up front that the lines are parallel. They just give you two lines cut by transversal, and they tell you that the corresponding angles are equal. That means that these lines are parallel. Well, we've got a bunch of other things that go from there. Now, that's a postulate. We don't have to prove that. But from that postulate, we can have some other theorems. And so we have a theorem that says this. I'm not going to write it word for word down, but we have one that says, if two lines are cut by a transversal, and if the alternate interior angles are equal, so everybody look up here. So if the alternate interior, if I could get this thing to work. Here we go. If the alternate interior angles are equal, I'll just put it in red. Doesn't mean it's equal to the 130 because it's got one arc, okay? They're just different. So if two lines are cut by transversal and we don't know that they're parallel, okay? Come on, grab that thing. There we go. If two lines are cut by transversal, and if I told you that the alternate interior angles were equal, what do you think I could say about my two lines right here? Girls, I'm up here, okay? Let's stop whatever's going on. Something's going on. Let's pay attention up here. So if two lines are cut by transversal, and if the alternate interior angles are equal to each other, what does that tell you about those two lines? Those two lines must be what? They must be perpendicular. What? Why would you say perpendicular? Do you see any right angles here? Okay, I appreciate you trying to answer, but you got to think first. Then the lines are what? No. The lines themselves. Lines can't be corresponding. They're parallel. That's right. So if I knew that these two angles were equal to each other, that tells me automatically that this line and this line are parallel to each other. That's what we mean by proving the lines parallel. Okay, that's what the beginning of the lesson said, the name of the lesson. So you could go from here, you could do a whole bunch. Look at the exterior angles. If you have two lines cut by transversal, and if the alternate exterior angles are equal, are they? Yeah, that's 130 and that's 130. That's 50 and that's 50. If that's true, then what's true about the two lines? Then they're parallel, okay? You could also do the supplementary thing, okay? You could say if the consecutive interior angles, that's this one and this one. Or again, I had a book that called them the same side interior angles. I kind of like that name a little bit better, okay? But anyway, if the consecutive interior angles are equal to each other, I'm sorry, not equal. If they are, what do you think? No. The consecutive interior angles, if they are, it's 130 and 50. If they're supplementary, then what does that tell you about these two lines right here? Then they're parallel, okay? You getting the hang of this, right? So if I know that these two are equal, I can say the lines are parallel. If I know that this angle right here and this angle right here are equal, I know they're parallel. If I could say that this angle here and this angle here are supplementary, what can I say about the two lines? They are, come on. The lines themselves. Come on, I'm leading you by your hand down the path, okay? Just follow along. If these two are supplementary, then what's true about this line and this line? They're parallel to each other, okay? All right? Does that make sense? All right. And we got one more, and then we'll finish. We have the same situation, kind of, but there's something a little bit different about our transversal. If you remember yesterday, we ended with one that was like this, okay? Now watch. listen. Listen, I only got a couple minutes. Just listen to me, okay? You don't need to comment. So look, I did not say that these two lines are parallel, did I? Okay, but I did put a transversal, and now watch what I'm going to give you. I'm going to give you that that's a right angle, and that's a right angle. Now, yesterday we said, this is what we said yesterday about this. If the two lines are parallel to begin with, and if I said that that's perpendicular, what could I say about this one right here? It's perpendicular as well, okay? But it's not what I'm saying today. Today's what I'm saying is I got two lines, don't know if they're parallel or not, but I got two lines cut by a transversal that is perpendicular to one and perpendicular to the other, okay? If that is true, what can I now say about these two lines? Now I can say that these two lines are parallel, okay? Just knowing that one is perpendicular doesn't mean that the other one is, all right? Unless I knew that they were parallel. But at the beginning of this, I didn't know they were parallel. But if I know that this is perpendicular and this is perpendicular, then they're parallel. Now, why would that be true? Because this is 90 and this is 90. And what's the relationship between this angle and this angle? They're equal. Give me the name. Give me the name relationship. Like alternate interior, corresponding, alternate exterior, all that kind of stuff. Consecutive interior. They're corresponding, right? So look, they're corresponding to each other. They're both 90 and they're equal, right? So if you have corresponding angles, and they're equal to each other, what must be true about the two lines? They got to be parallel, okay? So this follows from the corresponding angles. If we were to prove this, that's how we would prove it, is by using corresponding angles are equal to each other, okay? All right, that's kind of what you're doing here. It's very, very similar to what we did yesterday, but it's different because, again, what's the big difference? Yesterday, we started off with what? Oops. I keep clicking. I see these buttons right there, and I put my thumb on that button, and it makes it do weird stuff. All right? What did we start with yesterday? We started off with what? Two what? Parallel lines. Okay, today, we didn't say that the lines were parallel to begin with. We said that these corresponding angles are equal, or the alternate interior angles are equal, or whatever the case is, okay? And then, if we know that those angles are equal, then we could say the lines are parallel. There's a big difference. There's a big difference between yesterday and today, but there's also a huge similarity between yesterday and today as well. Okay, so let's, I already gave you the, what do you call that thing, the lesson plan thing? But I'll write it down anyway. So we're doing section 3.2. And it's pages 116, 117. And we are doing numbers 1 to 22. 1 to 22. All right? That's your homework. Have it done for tomorrow, and then we'll review for the test tomorrow as well.